Welcome everyone to our webinar series on building capacity for resilience-based management. We're thrilled that you are joining us. This series is delivered by the Great Barrier Reef Foundation's Resilient Reefs Initiative in partnership with our partner, the Nature Conservancy's Reef Resilience Network. My name is Amy Armstrong. I'm the Director of Resilient Reefs, and I'm going to give a very brief introduction to the initiative and the webinar series, and then turn it over to our speaker for today. The Resilient Reefs Initiative is a global effort to support coral reefs and the communities that depend on them to adapt to climate change and other local pressures. We're currently working with 5 World Heritage listed sites around the world, bringing together local partners and global resilience experts to identify new solutions to building the resilience. We provide a variety of support to sites, including creation and funding for a new leadership role, a Chief Resilience Officer. There's a couple Chief Resilience Officers on the webinar today. We provide technical support and capacity building in the development of a holistic resilience strategy that looks at threats to both the community and ecosystem. We have an amazing set of partners and a global knowledge network and connect our reef sites to those experts. And we, very importantly, have $5 million set aside to support our sites in implementation. So as soon as those holistic resilience strategies are done, we move into implementation and partner on on-ground action. We're piloting this work in 5 UNESCO sites, the Great Barrier Reef and Ningaloo Coast, both in Australia, the lagoons of New Caledonia, Belize's Mesoamerican Reef, and the Rock Island Southern Lagoon in Palau. Our effort really is about leveraging global partnerships for local impact, and so we have an amazing array of partners that you'll see on the slide. The program is funded by the BHP Foundation and delivered in partnership with UNESCO, the Nature Conservancy, Columbia University Center for Resilient Cities and Landscapes, Resilient Cities Catalyst, and AECOM. The webinar series came out of a desire from our 5 reef sites to be in better contact, to share best practices, to ask each other questions, and to leverage the network's expertise. We are putting together a series of topics that we think help support CROs understand and build resilience-based management, and so it has taken a variety of different angles. With that, I'm happy to turn it over to our guest speaker for today. Thank you so much.
Hi, good morning. Thanks to everybody for tuning in to this video. It's actually a redo of a call we had yesterday with the Reef Resilience Initiative to share information about the CNMI and the reef resilience work we've been doing for the last 10 years or so. Had a little bit of issue with the audio there, so I'm recording this one on PowerPoint from my daughter's bedroom. A little bit of a learning curve as I go through this process, so hopefully this will come out relatively smooth this time, and thanks for your patience in case this one's not perfect as well. I live and work on the island of Saipan in the Commonwealth of the Northern Mariana Islands, which is part of the United States. I think a lot of people forget that. Guam is just south of us, and the Marianas Trench is on the eastern edge of our EEZ. That's not a picture of me. That's actually a picture of James Cameron, who went down to one of the deepest spots in the world a couple years back. I've been here for 13 years working for the CNMI government agency first, and then NOAA's Habitat Conservation Division, bridging science, management, and regulatory activities, wearing a lot of hats out here really. I believe I was invited to do this talk and present this information for 3 reasons. Primarily, our work is relevant because back in 2012, we were the first region in the world to implement a study focusing on the priority reef resilience indicators that had come out of a McClanahan paper earlier that year. And the McClanahan paper was important for us because it narrowed our data collection need down to 10 indicators and gave us an achievable way to get at relative resilience scores for each of our reefs. So we didn't have to look at 60 indicators. In 2012, we essentially created a model to rank each of our reefs against each other based on how likely they were to resist or recover from bleaching events. In 2014, we did another study where we expanded our approach to 2 other islands, and we took a major leap forward by developing management queries to make site-level management recommendations for all of our reefs and watersheds. And then in 2018, we were able to look back at how we had predicted sites would do around Saipan in 2012 and compare it to actual performance after 6 years of massive bleaching and storm events. The global understanding of what is threatening our reefs has been building for the last couple of decades. For us, the transition to looking at reefs through the lens of resilience really started back in 2010. We'd put out a request for bids to expand the range of our long-term monitoring and integrate more climate metrics into our work. And what we got was a proposal by Jeff Maynard to take our current information and add elements of reef health and stressors and come up with a metric for resistance and recovery that we could use for management purposes. So if we just changed a few of our metrics, he felt we could actually come up with a resilience study rather than just an expansion of our monitoring. And that's what we did. If you look across the 3 major studies we have performed, each can be simplified to essentially 7 steps. I'll spend just a little time discussing each of these steps as part of the talk, but it is worth noting that for each step you probably have hundreds of decisions to make, correspondence to manage, and hurdles to overcome. Some of the steps require a high level of scientific expertise, while others require local and federal regulatory experience, outreach, fund management, and broad scales of coordination. Our work focused on reef resilience, but similar principles and approaches would likely apply to studies for community resilience as well. Funding for the CNMI work came across 5 different funding sources for the 3 projects, including both local and federal money, most of which we had to compete for. Jeff Maynard and I played the central role in all 3 studies, but with extensive contributions from CNMI's DCRM, University of Guam, and other NGOs. You might see yourself in this org chart somewhere. The CNMI work also had a huge amount of what I would call in-kind or matching support. Much of the field work was performed essentially for free by myself, CNMI staff, or students to keep our costs down. And Jeff would probably tell you that back in 2012 he did most of this work at a loss. During the talk yesterday, we came back to this slide for a couple of discussion points. One was just talking about financing, and I said I would guess that based on the in-kind and matching support we had, we probably cut the cost of what it would be to do this type of work by half to a third with essentially free support. So that's it. Finding key partners is really important. The other question was which of these partners were contributing to the research versus funding, and PICSC and CRCP predominantly provided funding, while most of those groups in the middle provided some kind of support, whether it was field work, boats, or helping us move money. Your decisions will be different than ours, so I won't spend too much time digging into all the variables, as each is really a story unto itself. For us, we had to first decide which variables from the McClanahan paper made sense for us to use. Then we had to decide if we could collect those indicators in a meaningful way, which for us meant field work and rather than data mining. So you may find yourself working more with other people's data, but we wanted to go get original data for most of our information. And we chose to align our data collection with how the CNMI agencies collect their data, so that we could more easily share and contribute to their long-term monitoring data sets and get local buy-in. For the indicators requiring desktop analysis, this involved a lot of new thinking and going back to the drawing board multiple times for each of our 3 studies. There was not an easy way to get at nutrient or sediment in our region, and fishing pressure, we had to use proxies. Once you know which indicators you want to collect, you need to decide where you want to collect them. Your options here will vary a lot depending on how much original data you plan to collect as part of the work in your region. For the work in the CNMI, we opted to start our survey effort at CNMI agency long-term monitoring sites, all of which were at the 25-foot contour on 4 reefs. We then did our best to fill the gaps along the contour every time there was a major change in the makeup of the reef, more than tripling the site coverage to 78 sites across Saipan, Rota, and Tinian. We could have added different depths, and we could have tried to integrate known recreation or dive sites, but for the purpose of this study, we tried to create a census of what was happening at 25 feet across all the island. It ended up being a mountain of data for each of our 10 indicators. You can see by the information in the graphic there, that's really just from 2012 and 14. There's another third more data and fish counts than is seen there, and that's me in the photo, over 100 dives, which is what keeps you going in this type of work, being able to be involved in the field data and seeing what's happening out there. We also came back to this slide in the discussion yesterday to talk about what would happen if you're looking at larger spatial scales. So if you're not just at the island, or in our case 3-island scale, and also what would happen if you're comparing more diverse reef areas. So if you're not just at the 25-foot contour, but if you're up shallow and then out at depths, and then maybe some fringing reefs versus some back reefs, and how do you integrate those different types of reefs into this kind of work. And we didn't actually have a solution yesterday. I don't think anyone does, but most of the work that's been done on this, like the work in Hawaii, they tend to separate the different reef types to compare them to each other rather than comparing them across types or depths. So if you have a huge data set with a lot of different reef types and depths, perhaps you can cluster them together based on the ones that are most similar for your relative comparisons. So you're not comparing a lagoon site to, say, a 4-reef site. Once you have data for all your indicators at all of your sites, you're ready to calculate your overall relative resilience scores and rank the sites. At some point, most resilience studies will have a big table like the one you see on the right, where each indicator is normalized, converted to a score, summed up, and compared against all of your other sites to give you a suite of resilience rankings. In our case, none of the sites scored high or low on all the indicators, but we were able to tier all 78 sites as relatively low, high, or somewhere in the middle. The highest ranking site for us in 2014 was Nanasu Reef, so that's what's at the top of the table there, even though it's kind of blurry. It had high scores for coral recruitment and herbivore biomass, so those are the green boxes, but it actually had low scores for some of the other indicators, like temperature variability and bleaching resistant corals. But when summed up across all of our indicators, it came out on top. Scaling ended up being a major discussion point for us because we didn't necessarily think that all of the indicators should be treated equally. But nudging the numbers also felt a little bit arbitrary. So we went back and forth on whether to include scaling in each of our studies. And in the end, in the 2018 work, we ended up not using it again. Your big resilience table can then be converted into nice maps to help you identify which reefs have the greatest relative resilience within your region. Here, the red circles were the low scores and the green the high. In looking at the data this way, you could quickly see that Rota generally had lower scores than the other islands, which came as a complete surprise given how low the human population is there and how well known it is for abundant fishing. This also came up in our discussion afterwards because in the end we realized this difference is driven by connectivity, and it turns out that Rota is not a very good source or sink for larval transport, which drives down the diversity of corals there, which was the reason why it trended toward these lower scores. So connectivity could be a big factor in your work too. You can also identify which indicators were the main drivers in generating the scores across your whole study area, at the island scale or even at the site level. In our 2014 study, we found that coral recruitment and herbivore biomass numbers tended to have the greatest range and thus ended up being the main drivers of our overall resilience scores, while variables like temperature variability really didn't vary enough across our sites to have much of an effect on the overall scores. You can also take this data and do all kinds of really complicated statistics if you want to. We did principal coordinate analysis and several other things to try to get at exactly what was happening at our sites. In 2014, we also developed an encyclopedia page for all 78 of our sites, which we thought would be useful for managers doing work in the water or watersheds above any of the sites. This was a considerable amount of work and took a fair amount of arm twisting by me to make happen. We knew it was going to be expensive and a heavy lift. We wanted to do it because it was the first go. It ended up being a really great product, but it isn't clear how much it was actually used outside of our team. But here you can see what we included on our encyclopedia page for a site. There's a narrative about it, the resilience scores and how they added up, details about the benthic and fish communities, and then complete species lists because those ended up being pretty important. And in 2012, that's essentially where we stopped our process. We delivered the maps, and the appendix information, and expected managers to run with it. And they didn't run with it. So in 2012, we decided to expand our efforts to do a better job and provide more tools to help bridge the science to the management recommendations. First, we brainstormed all the types of management we thought were relevant for our region and that had a prayer being supported by local political climate. So for us, that meant leaving out things like marine protected areas because the monument in our region and existing marine protected areas were already a pretty contentious issue. We also needed to decide if the corals would be, or which corals we would focus management on. Are we going to manage those sites that are highly resilient and try to protect the strong, or were we going to try to lift up those weaker sites? And in 2014, we opted to prioritize the more resilient sites for management action, hoping to give them the best chance to continue in this current climate conditions. I won't go into each of the management queries, but looking a bit closer at land-based sources of pollution gives you an idea of how it worked for each of those management targets. On this graphic, all of the purple sites had above average resilience overall scores and an above average score for risk from LBSP based on the land use metrics we had for the watershed. So the watersheds above each of these reefs could be considered a good target for projects that limit the movement of sediments and nutrients. We also included a list for the types of management measures we thought specifically might be useful for projects to support the target, so broadly recommending things like road improvements above a particular area. In total, 55 of the 78 survey sites from 2014 met at least one of the 6 of our query criteria. We have since realized that even this level of recommendation is too broad, and if you really want local managers to implement a project, you need to identify something even more specific and targeted. But at that point, you end up creating something more akin to a conservation action plan or a watershed management plan, or you just end up implementing a project yourself. So at this scale, seeing an area like the southern part of Saipan, where so many different types of management queries were recommended, can also help managers identify locations to take that next step. If I was going to look for a watershed to do a new conservation action plan or develop a habitat priority area, I would probably look to the southern part of Saipan based on this data. Following each of the studies, we spent extensive time rolling out the information, meeting with local agencies, circulating reports, publishing, and trying generally to share with other practitioners to the greatest extent that we could. And we came back to this slide too after the discussion to talk a bit more about community engagement. So we did talks on Saipan, public talks, and we tried to get the information out to the media. I believe there was a newspaper article and interview also with the news. Just to share this information, but Saipan is a tourist community, and it's fairly well westernized, so it's not a village structure like maybe some of the other locations where this work's happening, where you might need to roll the information out specifically to a village chiefs or something at that level. That was not something that we needed to do. Definitely more of a Western approach here. We found that the local capacity at CNMI agencies limited their ability to use the information or integrate it into new management priorities. And this was in part driven by our recommendations still not being detailed enough to identify shovel-ready or targeted projects. We found that certain information, like the site-level species lists, were highly valuable for federal partners. The biggest practical application of this work has been its link to restoration, informing us where to collect and outplant corals, but also acting as the main driver in a region-wide shift to prioritize restoration. The first nurseries in our region all started after the findings of our 2008 work were released, and it completely changed where I personally put most of my conservation energy. And we found that our lessons learned, as one of the first to undergo this process, probably generated the most use as Jeff took the show on the road, and this framework became widely used after the 2012 study and integrated into broader initiatives. Most of what I've shown so far was from 2012 and 2014, which preceded the major bleaching events and storm events that the CNMI has experienced over the last 6 years. So right after our work in 2014, we had a major bleaching, and then we had a minor bleaching in 2016, and then in 2017, we had just incredible losses. This is important because it gave us incentive to revisit our reefs and determine demonstrated resilience. And in doing that, we learned a lot about what we had done right and wrong during our previous work. So we went back to our playbook, found funding to revisit Saipan, and went through the whole process again. We found that the field had evolved considerably since the 2014 work, and we also found new and improved data sources for some of our indicators that were developed from the desktop analysis. We also realized just how important it is to have consistency within the personnel and approaches used to collect the field data if you're trying to do a time series like this. We revisited all the sites around Saipan with essentially the same team doing the same in-water methods. This high level of consistency allowed us to compare across years in a way that most studies are not able to achieve. Despite our intensive efforts to create consistency between 2012 and 2018, we did end up having an issue with observer bias in our line point intercept surveys, which ended up making it virtually impossible for us to integrate macroalgae metrics into our comparison between years. So if you're mining data sets or pulling information from different sources for your comparison, you might want to consider this a cautionary tale, because you have to be extremely careful with the data, because small deviations can be caused by something other than what's actually happening in the environment and skew your analysis rather quickly. And on this map, you can see the percent change in coral cover at each site. We knew the situation for our coral reefs was bad, and our data confirmed it, with only 3 sites in 2018 that didn't show a significant loss in coral cover. We lost 60 to 70% of most of our branching corals. When we reran the rankings with our new data, we saw major changes between the years. A few of the sites had demonstrated resilience in 2018 that matched the predicted or relative resilience in 2012, but fewer than we had anticipated. The northeast side of Saipan is the best example of this change, where the sites we thought would be the most resilient in 2012 ended up demonstrating relatively poor resilience after the stress of multiple major bleaching events. The pictures that I have comparing across those years up at Bird Island floored some of our local leadership. And I have it here as a hidden slide. You guys won't be able to see it on the recording, but yeah, the pictures are quite telling when we have a before and after for those types of events. As you might expect, the management recommendations based on queries also changed dramatically for each site once the resilience ranks changed. The clearest example is the southern part of Saipan, where the alphabet soup from 2012 was replaced by just a couple positive query recommendations in 2018. In part, this is because these approaches are so new, and we completely retooled the way we calculated sediment and nutrient impacts through LBSP. But this is also driven by how recently our reefs have been bleached, and the fact that sites didn't have a chance to show any level of recovery, which was a major component of our 2012 resilience scores. We'll talk more about that. Here we have separated out the resistance observed versus recovery potential for each site, and you can see that for most sites there's a difference. Typically, if a coral on site are the type that we would expect to resist bleaching, they're not the type that we would expect to quickly recover. In fact, the resistance specific scores are a much closer match to what we saw in the 2018 demonstrated resilience rankings. And if you don't have data to document recovery at the right timescales, like our surveys, which I think happened just too soon, within a year after the major bleaching event, then you can't really say whether or not the site has a full suite of demonstrated resilience, because you haven't documented whether or not it was able to recover. We found that to really get at demonstrated resilience, you will need to go back and monitor sites twice after an event. Once shortly after the event to document the resistance, and then again at some future time to document recovery. So it becomes a survey challenge, to say the least. Our next study will likely be focused on getting at that missing recovery metric. Given the circumstances in the CNMI, our team has concluded that we need to think more deeply about our game theory and prioritization, especially if we are lumping resistance and recovery together. Our project team from 2018 work is still trying to translate the demonstrated resilience scores into prioritization and better management recommendations. I've been working with Dr. Liza Johnston on this graphic, which is an entirely new way to think about this data as we work to decouple resistance and recovery. So probably you haven't seen this before unless you were on the call the other day. This diagram regroups the sites looking specifically at coral resistance versus recovery potential and the type of management actions that would benefit each. So you could use this graphic in concert with our other management queries approach. This is especially useful if looking across sites to prioritize for restoration, which is becoming a major theme for us and globally. If I was to list a few of the overarching lessons learned from our work, it would be to first bring in as many partners and get as much buy-in as you can to increase the potential for management and potentially cut your costs. 2, make decisions about approach and prioritization that are specific to your place. So we use the McClanahan paper almost exclusively, trimmed those numbers down a little bit, or those metrics, but we might have chose some different ones if we were thinking specifically just about our needs and what was available to us. Think about the possibility to follow up studies and how to generate as much consistency as possible. And if you're using mostly mined data, you may need to just stick with that single agency's data over time rather than trying to blend across different groups and different data sets. And I know it's going to be impossible for places with huge geographic ranges and such, but the consistency of the data coming in is going to drive a lot of the comparisons between these scores, so it's something you need to keep in mind. and look closely at coral resistance versus recovery and whether you can separate those variables. Our efforts to separate those variables after the fact have been somewhat useful, but I think if we'd done that up front, it would have generated different results. And keep restoration applications in mind, because that seems like where the future is headed, and I know that's what we're doing out here in the CNMI. Okay, well, that's a wrap. Thanks for your time. I'm really hoping that this PowerPoint recording came out clear enough, and that the volume's good enough, and that it's not too stuttered for you. Again, you can reach out to me by email. There's also a conversation in the Reef Resilience Initiative webpage, so you can ping me there. Appreciate your time today. Thank you.